Hello, Keith Rucker here, VintageMachinery.org. Guys, today we're going to be working on this big frame or the main bed of my planer that I'm in the process of restoring, and I'm going to be trying out something new for me. In fact, you're going to get to witness it from the very beginning. I'm going to try a process I haven't ever used before, but I've been interested in for a while, and that's basically using a pressure washer as a sandblaster. So I recently purchased a pressure washer for the shop. I've been using one for years. I've been borrowing one from other people, and I finally decided I just need to get one for myself. So picked this up at my local Lowe's. It's 3400 psi, made by Simpson, and it's been doing a great job. I've been using it for mainly just cleaning parts off of this metal planer, coming out here with degreaser and stuff, getting the grease and the gunk and stuff off. Now though, I'm getting down where I need to get this thing cleaned up and prepped for painting. I need to get all the old paint off. I need to get it basically down to the bare metal. And yeah, typically I come in here with a wire wheel and do that. So an awful lot of surface area to be doing by hand with a wire wheel and an angle grinder. Wanted to look at sandblasting, but you know, I don't have a sandblaster set up here. Really, there's not a whole lot of options for me locally as far as going and getting that done. So I decided I'd try this out. So what I've got is, this is an adapter. I bought it off of Amazon. It cost about $100, and it's got a little Venturi thing on the end here that hooks onto the end of the pressure washer. As the water goes past it, basically it creates a vacuum in this hose here, which pulls up from a bucket of sand. And I got a bucket of sand down here, and you got a blast nozzle here, and if it works as advertised, we should be able to come in here and sandblast this thing. Now, one of the advantages of wet blasting over regular sandblasting is because we're using water as a carrier here rather than just air. You don't really get all that airborne dust like you normally do from sandblasting. So, you know, normally you have to suit up with respirators and everything, and I'm probably at least going to still wear a dust mask just to be on the safe side. But from everything I've heard, you really don't get all that dust where you have to worry about like you normally do from regular sandblasting. So we're going to give this thing a try and let you guys see how it works. I've seen a couple of these on YouTube videos and so forth. I've talked to a couple of guys who have used them. They say, well, you know, it's not maybe quite as effective or as quick as a regular sandblaster, but it gets the job done. And it's something that's relatively inexpensive that I can use with my pressure washer that I already have without having to go out and buy an expensive sandblasting kit and a suit and everything else to go along with it. So we're going to give it a try. That's actually not doing a bad job. I mean, I'm getting down to bare metal here. It's taking a little bit to get that rust layer off, but it's getting there. I maybe need to make some adjustments to this thing and try to figure out So let me give you an update of where we are on this project right now. So we got started wet blasting out there, and honestly guys, I ran into few problems. Things started getting a little bit frustrated. My camera equipment was getting wet. It was thundering and lightning, or at least thundering. We never did get a storm here, but I felt like there was a storm coming. I shut the cameras off, started trying to solve some problems. Bad news was that the sand that we had, that little play sand, just wasn't coarse enough. It really wasn't cutting the material and really blasting it like it needed to. So I did a little bit of experimenting around, and we changed over to a different type of media, and things actually got a lot better. So I'm going to do another video probably when I work on the table and really kind of show you a little bit more about the sandblasting setup because it worked pretty good. Like I said, there was a little bit of just trying to fine tune things to get it right. But mainly because it was thundering and I thought it was going to start raining, and I wasn't worried about getting wet. I was already wet. I was worried about lightning, so I was trying to get done out there. So we just kind of shut the cameras off during that. But we did get the base blasted. I will say this, if nothing else, it really worked good because down up inside of this thing I had layers and layers and layers of caked on grease that had been 100-year-old grease that had been just on this thing, and it was really hard to get cleaned up. The wet blasting was just the trick, man. It just took it right off and got me down to the bare metal. Now I did have some issues with flash rusting, and once I got it back in the shop, I had to actually get the wire wheel out, lightly hit it just to clean it up. We got it dried down, and I did go ahead and put this gray coat that is on here is just a primer coat. Normally I don't prime cast iron, but in this case, because of the flash rusting, I wanted to get a protective coating on there. So I went ahead and we put some primer on it. Now, the inside of this, as you see, is this kind of dark red color. And that is what I'm going to go with in the final paint. That is the final paint in there. And whenever I was cleaning this up, it was very obvious that the inside of this planer down in here was all painted a dark, almost rust-looking red color. Almost looked primer, like a red primer, but you could tell it was paint. It was not primer. So anyway, kind of emulating that, I'm going to go with that red color on the inside. I've got the casting right now flipped up on its side so that I clean the bottom up, the side that I'm standing on, and there was some painting over here, which is why I went ahead and started painting that red and just went ahead and got it all painted while I was at it. Next step for me is I want to try to do some inspecting on this casting. We did some inspecting on the table, but I want to see what the ways look like on this. And it's a little bit more complicated because I don't really have surfaces I can measure off of, but I do have an idea how we're going to do it. But what I need to do is I need to get this casting turned back up on its bottom. I'm going to set it over here on my welding table. I'm going to get it set up on 3 points with some planer jacks or machinist jacks where I can level it in both directions. And then using my Kingway tool, we're going to come through here and actually try to do some inspecting on it. So let's get this casting flipped back over and over there, and we'll bring you along for the ride for the inspection part. Well, it's inspection time here, and this has turned out to be a little bit more of a challenge than what I really first anticipated. So let me tell you a little bit about what we've done to get ready for this, and then what we did to actually do an inspection. So first off, I've got this thing sitting up on 3 points. So I have 3 planer jacks or machinist jacks that are up underneath this, one here, and then I've got a little crossbar going across and doing in the middle. Why on 3 points? Well, mainly because it made it easier for me to level this because I was going to use the Kingway tool, which uses levels, and I wanted to level it with my precision level in both directions. I did all that. I then came in here with my Kingway tool. Let me just zoom in and kind of show you this Kingway tool and tell you a little bit about how it works. This is what's called a Kingway tool. It was actually invented by Richard King's father. Richard is the guy who helps teach our scraping classes, and he was a master machinery builder, and he came up with this idea of a way that he could inspect ways and so forth on machines over a long area, which is exactly what we want to do here. So we got this thing coming in here, got a kind of a tube on this side. It's actually bigger on the end, so I'm basically sitting on 3 points, and I got a ball sitting in the joint over here, or in the ways over here. Up on top, we have, again, some precision levels. These are actually very high accuracy levels. I don't remember exactly what these are calibrated to. I was going to use this. We ended up going a different route, and I'll explain why in a minute. But these are set up where you got some adjustments in here, so you can adjust the levels and get them where they're basically level. And then you can slide this whole rig down, and you can read on the levels how much it's moving in one direction or the other. Now, these levels are actually calibrated. I don't remember exactly what each line in here is. I know on my stair it's a half a thou per foot, I think. But I ended up not using this, so I didn't really go to look it all up. But you can basically use these levels as a measurement tool. And what it's doing is it's telling you a change in angle as you go across. So as the bed wears, it's going to start pointing up or down as you move across. So why did I end up not using this? Quite honestly, these are very accurate levels, and they have a very short travel range. They're only going to be accurate. They can only measure differences, probably a couple of thousandths of an inch. Let's just say 10 thousandths of an inch. I'm really not even sure because I never even got to that point. Bottom line is there was more wear in the bed of this planer than I could measure with the calibration of these levels. I mean, I probably could have cheated and zeroed it out and moved it down and re-zeroed it out and kind of added my error together. It made it work, but it was going to be kind of clunky, and I just decided, you know what, let's step back and look at this again. So let's do that. Let's step back and look at it again. So in my first video that I did on measuring machine wear here, I talked about you can use an unworn original machine surface and use that as a reference. And so I got to looking on here, what can I reference the tops of these ways off of? And then I remembered, because I just had this machine flipped over where I could see the bottom down here. The bottom side of this planer has been planed. So they actually put this on a planer, they planed the bottom surface down here flat, and then they set the whole planer bed on a larger planer, and they probably planed out the ways here so that they would be parallel and concentric to each other. Not concentric, but parallel to one another, so forth. And I noticed when I was cleaning this up that this bottom surface down here was in excellent shape. You can still see the planer marks in it. Is it pristine? Arguably not, but it's going to be pretty darn close. This is not a wear surface. There was nothing wearing on the bottom of this planer. There was basically 3 places that there were legs that were attached, but other than that, it was planed all the way across. So what I ended up doing was I took a pin here. Ideally, you would use a gauge pin. I don't have a gauge pin large enough to do this, so I just used a piece of round stock. I made sure that I put some marks on here where I was always making sure it was in the same place and I was measuring in the same place. And then I used a big set of Starrett dial calipers to basically just come up from up underneath the bottom of the machine on that machine surface down there, and come down to the top of that pin. And that enabled me to get measurements and basically go up and down this thing. It's probably not going to be accurate to a 10,000th of an inch, but it's probably going to be more accurate than a 1,000th of an inch. But since I'm measuring in thousandths, the wear is so great anyway, a 1,000th was all I needed to measure to. And what I did was I just went down through here and I wrote the actual readings down from one end to the other, and then did the math to figure out. Basically made my my smallest measurement a 0, and then everything was a plus off of that. Let's show you what it mapped out as. So we'll start down here on the end, and when I measured this, it was 12 inches 100 thousandths. This is a 12-inch caliper. They'll actually go up to about a 12 inches 250 thou. So I was actually able to measure a little bit over that. If that had been a little bit longer, I probably could have got a smaller pin to put in here and been all right. But I was able to measure all these. But turned out this was 100 thousandths. I just wrote down 100 thousandths because we're just going to drop the 12 to make it easier on the math. But that made it real easy because it was 100. Come over here, 103, 105, 110, 125, 125. I wasn't able to measure here because this block was in the way. Dropped back down to 110, 105, and then, believe it or not, it went back to 100. So the wear was the same on either end. The high part is the middle. Pretty much almost an exact wear pattern to what we saw on the planer bed that goes back and forth on here. Honestly, I was kind of expecting it to be worn more in the middle and less on the ends, but the wear on the end, and ironically, I think on the planer table, the wear on the ends was about 20-25 thou. So very similar wear, where it wore very evenly. So I know there's been a lot of discussion over on my first video about the wear pattern and why it turned out that way. And so let's talk about that. Let's talk about it because it really kind of makes sense. So you've got this planer table. You got the inverted V-ways that are going down in here on either side. That planer table is actually coming out past the end of the table. So on a full stroke, it's probably going out 2 or 3 feet past the end. So actually the ways come out and are exposed. When that happens, if you think about it, the weight on that table is going to be kind of cantilevered out on the end, and that's going to cause a little bit more weight on the ends because it's heavier down there. In the grand scheme of things, it's not by much because that bed is so heavy. That table's about 8 foot long. You've still got most of your mass on the table, but still you're going to have a little bit more wear on those ends. So, and then when it drags back across, you got that extra friction. Another thing that happens is that your ways become exposed on these ends. So when the table comes back this way, you've got a section here where you got an inverted way. It's got oil in here, grit, dirt, metal chips, etc. Get down in these ways. And then when that end comes out, it can get trash and stuff in between it. That becomes an abrasive, and that's going to cause our ends to wear more than the middle. So at least that's how I'm going to explain it. It makes sense to me, and that's what we're looking at here. So the wear on here, basically, I'm just going to say it drops off about 25 thou on each end, high spots in the middle. So we're going to end up having to grind out of this bed about 25 thou on both sides. Probably we'll end up having to go a little bit more than that to clear up any gouges and score marks that are in here. Who knows, we may even have to take as much as 50 thou off of this, and up to even 50 thou off of the table over there. Not a big deal on a planer. The only thing that comes in contact from an alignment standpoint is there's a bull gear in here, and you got a rack on the bottom of the table that drives on that bull gear. So if I drop everything down, that is going to bring those gears closer together, but it's fairly easy. We can take whatever measurement we need to when we're grinding this. We can actually take that off the top of the table or the bottom of the table where the rack mounts to, and compensate for that metal that we take out of here. So anyway, that's kind of what we're looking at here. It's definitely something I want to get these ways addressed. Again, arguably, I could probably put it all back together and it would probably work good enough for most jobs, but I really want to do this job right, and I'm going to send it out. We're going to get this thing reground. I've been in talks with one individual that I've worked with before on some grinding, some big stuff, and we haven't worked out all the details yet. I got to give him a little more information, but it looks like I got a place to send this thing to someone that knows what they're doing, who works on this kind of equipment, and is going to be able to help me do that. Price, don't know yet, haven't gotten that far into our conversations, but we'll keep you guys informed. So anyway, that is where we're at. That is where we're at on this project. I have now got an idea of what the wear is on both parts. I think I'm going to go ahead and get this casting all painted up before we send it off to get it ground. I'll probably have to touch it up afterwards, but just to protect it more than anything else. And next big thing for me to do over here is to get my table cleaned up and get it painted and stuff and ready to send out. While I have everything sent out for grinding, I can work on everything else over there that needs to be worked on to go back together once we get it all back. So anyway, there you go. Well, there you go, guys. That's going to be a wrap on the planer base here. Like I said, I'm going to do some painting off camera. You guys don't want to watch painting anyway, but we'll get this thing ready to send on up and hopefully get some grinding done here before too long, get this thing worked out. And I'm going to do some more wet blasting on the actual table, and I want to do a little bit more of a video on that. I know I kind of started this video showing some of that, but we didn't really get a chance to show it like I wanted to, so we'll come back to that for another video down the road. That'll be a wrap. As always, guys, thanks for watching. Please leave comments if you like. Please subscribe to the channel if you haven't already, and we'll catch you on the next video. Thanks for watching.